There are two special kinds of right triangles in geometry. One is a 45-45-90 triangle and the other is a 30-60-90 triangle. This video is all about 30-60-90 triangles. If you would like to learn about 45-45-90 triangles, make sure to click here to watch that video. So let's first label the sides of a 30-60-90 triangle. All right, so across from the 30-degree angle, you're going to go across from there and label that side X. Then I find where the 60-degree angle is, and I go across from that, and that side is going to be the side X times the square root of 3. So it's going to make that side even longer. And then the hypotenuse, which is the side across from the right angle, that's always going to be 2 times X, or 2 times the side length across from 30. Let's go over a couple examples. So in this 30-60-90 triangle, let's say I made X equal to 5. Then across from the 30-degree angle, that would be 5. Across from the 60-degree angle would be X root 3, or 5 root 3. And then the hypotenuse would be 2 times X, or 2 times 5, which is 10. All right, now let's say X was equal to 20. Then across from the 30, that side would be 20. Across from the 60, 20 root 3. And then the hypotenuse would be 40. And those are a couple of nice, easy examples. But I think we're ready for some more challenging ones. Let's look at the first triangle here on the left. We are given the side across from 30, so that means we have been given the X side. So then if I want to fill in the side across from 60, that would be that side times the square root of 3. And then the hypotenuse would be that small side 3 times 2, which is going to be 6. But what happens if we're given the hypotenuse now? Notice we are given the side across from the right angle, which is the 2x side. I'm going to create an equation so that I can solve for x. So I'm going to say if 2 times x were 9, and I divide both sides by 2, then x must be 9 halves. Well, there is my side across from 30, which is x. So then I would go across from the 30-degree angle, and I would label that side as 9 over 2. What I have left is the side across from 60, which is the side x times the square root of 3, or the side across from 30 times the square root of 3. That would be 9 over 2 times root 3, or 9 root 3 over 2. Now for the last example, it looks like I'm in the way, so hold on tight. I'm gonna move right over here. All right, so in this third example, we are given the side across from 60. This is going to be our most challenging problem, but I know we can do it. So the side across from 60, well, that is our S root 3 side. And once again, did I say S? You know what, sometimes that's used in math classes, so I think that's kind of habit, but we've been using X. So let me go back and we'll put an X there. So I like to write an equation. I say, okay, they give us the X root 3 side, which is equal to 10. I'm going to solve for X. And in order to do that, I'm going to divide both sides by root 3 so that those root 3's will cancel out. And I have X is equal to 10 divided by the square root of 3. We'll go ahead and rationalize that denominator. If you need a helpful reminder of how to rationalize the denominator, make sure to click this video here in the upper right-hand corner for a reminder. Once this fraction is rationalized, that would simplify to 10 root 3 over 3, which notice is my x side, the side across from 30. So if I go to the side across from 30, let me fit this over here, that would be 10 root 3 over 3. And then the hypotenuse is going to be that side times 2. Because that's my x, so then the hypotenuse would be 2 times x. And if I multiply 10 root 3 divided by 3 by 2, that would be 20 root 3 over 3. And that is your 30, 60, 90 special right triangle. If you found this video helpful, make sure to click subscribe in the lower right-hand corner so that you're informed when new videos come out that can help you in your math classes.